Right, question 7. This is a classic thyristor question. The first part asks you, state 2 conditions necessary to make a thyristor conduct. Now this is simple, there are generally only 2, so you just remember the 2. It's that there must be sufficient current to the gate, and if you can, try and remember to say sufficient as well, because sometimes you can have a very low current and it won't conduct. Remembering that this part here is the gate, okay? So, and then the second condition is that it must be a forward bias. Now this, of course, means that it's going positive. The point is going to be going away from the positive. If you imagine the current coming through here, if it was the other way around, pointing up this way, the current's going to be coming through here, and that's going to be negative bias because it's not going to be able to go through there. Think about ET2 with Zener diodes and all of that. So, nice and simple, nice 2 marks. Part B says, the diagram shows part of a circuit in which a thyristor is used to control a heater. You see the heater here, I've labelled it H. Now, the first part you need to realise for every question is to watch what's going on here. Is that 24 volts? Have we got 0 volts? If this is minus 12 and 12 up here, what's the supply voltage? Remembering that the supply voltage is going to be 12 minus 12, which is 24. Just remembering things like that, because that can really catch you out when it comes to doing this question. But here we've got 24 volts, 0 volts. So we're looking at 24 volt supply. Now, it gives us a table, and it says complete the table by adding the values of VT, that's the voltage across here, and VH, that's the voltage across here, at different times dependent on this switch, S1. So the first one says it's initially off. Now that of course means that this is initially open, so there is no current to the gate, remembering that. So across the thyristor, there's going to be 24 volts dropped. And across the heater, there's going to be 0 volts dropped. That's because the thyristor is not going to be conducting, it's not going to be allowing current to go through this heater, if that makes sense. Now, it now says momentarily on, so you switch on, we've now got a current pulse to the gate, we're in forward bias, so the heater is now going to be switched on. Now this might not seem to make sense why we're having 0 volts across the thyristor and 24 across the heater. But if you remember that the thyristor works as like a switching system. It is a switching system. So you're thinking about how this whole system here is going to be affecting the heater. Now, when the thyristor is conducting, that means there's voltage across the heater. That means the heater is being switched on. So there will be no voltage across the thyristor, but there will be across the heater. So try not to get confused that current to the gate means that there will be voltage. It doesn't. Current to the gate means that this will conduct and there will be voltage across here of 24 volts, meaning the heater's on. It then says switched off again. And there's one other thing you should remember, and if you've read your notes you'll know this, and that's that a thyristor is key because it will stay on even though it's switched off. So all it needs is that one pulse of current and it will stay on until disconnected. So that's now going to stay at 0 volts and the heater's going to stay on. So it's like the light switches in the classrooms at college. You click them once and they come on. You don't have to hold the switch down. You just click it once, the pulse comes through and they go on. Nice and easy. And if you just remember this arrangement with 2400 and then remembering it's the opposite way around across the heater, that's how I like to remember it. One other point is that if you've got the heater here underneath the thyristor, you have to then remember that anything underneath this is going to be at 0 volts when there's a pulse. So that means, of course, that this is going to start off at 0 volts, that's going to be 24, and then when it's switched on, it's going to be 24 and 0 volts across the heater because it's going to conduct and there's going to be nothing across this part here where, of course, the heater may be laid out. I've seen one question like that before where they've sort of tricked us with that. So, the next part then gives us another table, which I haven't managed to write out yet, which gives us quite a lot of properties for the thyristor. And it asks us, use this table to calculate the maximum ideal value for this resistor R. Now, you're looking for some various bits of information. You know, some of it's relevant, some of it's not. The relevant parts are anything with the word gate involved, because this is the resistor to the gate. And it says here, gives us maximum forward current, holding current, gate voltage, reverse voltage. You're looking for the two things with gate in the name. That's gate current and gate voltage. So, if from this table it tells us that there's going to be 2 volts across the gate, that means in total here, if we've got 2 volts dropped across this gate, we're going to have 24 minus 2 to work out the value for this resistor, because you've got 2 volts here, and how much is going to be dropped across here? That's going to be 22, because 24 minus 2 is 22. So it then says we have to have a minimum gate current of 60 milliamps. Now if you think to what we were saying before about current to the gate, that means that the minimum that can be is 60, which means that we're working out the maximum this resistor can be, because if it went any higher, the gate current would be too low to make the thyristor conduct. So we're thinking about the switch is pressed on, we need a certain amount of current to be going through this resistor, and that's 60 milliamps here. So we know we've got a 22 volt drop across it, and we know that we need 60 milliamps to be going through it. So nice and easy, 22 divided by 60 milliamps, which, as I worked out before, gives us 367 ohms. Nice and easy. Remembering, obviously, I'm using Ohm's law to work that out. The final part of the question says, complete the circuit diagram by adding another switch and other components needed to turn off the thyristor during using capacitor commutation. Now, generally if someone tells you they need a switch, you know you need a resistor somewhere. And there's no real way that I know to work it out. You just remember from the notes that capacitor commutation looks like this. And that's a capacitor here, a switch here. So there's your capacitor, there's your switch. Capacitor C, switch S2. And like I said before, switch needs a resistor. So in comes the resistor, and that's the third mark. So you've got 1 mark, 1 mark, 1 mark. You know that the switch has to be connected to the 0 volts, and the only way to know that is just remembering capacitor and switch here, and then filling in resistor as filling in the last piece of the puzzle there.